into this world of science, exploring the most cutting-edge topic, that is artificial intelligence and healthcare, that shapes the future of our world. May I take the privilege to invite our distinguished guests onto the dais. Dr. C.H. Mohan Rao Garu, President, Telangana Academy of Sciences, former Director, CSIR, CCMB, and Head, Department of Biological Sciences, BITS, Hyderabad. I welcome you, sir, onto the dais. Our chief guest, Padma Vibhushan Dr. D. Nageshwar Reddy Garu, Chairman, Asian Institute of Gastroenterology and AIG Hospitals, Hyderabad. Guest of honor, Dr. A.G. Rao, Chief Scientist, CSIR, IICT. I request Purnima to give the bouquet to our chief guest. And request Shambhavi to give a bouquet to A.G. Rao Garu. I request Professor C.H. Sanjeev Reddy, C.H. Sanjeev Reddy Garu, Vice President, Telangana Academy of Sciences, to come on to the dais. Professor S. Satyanarayana, General Secretary, TAS, former Vice Chancellor, Usmania University, to come on to the dais. Professor B. Seshikiran, former Director, NIN, Hyderabad. Please come on to the dais, sir. Professor A. Ramchandraya, Editor of Publications, TAS. EC members of TAS, Professor V. Ravinder Garu, Professor K. Lakshma Reddy, Dr. L. Giribabu, Professor P. Venugopal Reddy, and Professor P. Prakash Babu onto the dais, please. I now request Professor S. Satyanarayana, General Secretary, TRAS, and former VC, Usmania University, to deliver the welcome lecture. Welcome address, sorry.
Good afternoon to everyone. A warm welcome to all the delegates and the scientists present here. It is a great pleasure to have you all here today. It is a moment of extreme pleasure to welcome our respected chief guest, Padma Vibhushan Dr. D. Nageshwar Reddy Garu, Chairman, Asian Institute of Gastroenterology and AIG Hospitals, Hyderabad. Madam Srimati Indra Devi Dhanrajgiri Garu, of course she is not here due to ill health. Our guest of honor, Dr. A.G. Rao Garu, Chief Scientist, IICT, Dr. Mohan Rao Garu, President, Telangana Academy of Science, Dr. Seshikiran, former Director, NIN, Professor Sanjeev Reddy, Vice President, Professor Ravinder, Joint Secretary, Professor Ramchandraya, Editor Publications of Telangana Academy of Science, all the members of the Executive Council of TAS, Fellows and Associate Fellows of the Academy, and eminent scientists, distinguished guests, academicians, and all other invitees, young students who came here to attend Dr. Nageshwar Reddy Garu lecture, press and media person. As you are all aware, that the aims and objectives of the Academy are mainly advancement of science and technology by providing a forum for discussing scientific programs, scientific knowledge among the people by conducting seminars, symposia, workshops, endowment lectures, publication of books and journals on science. Further, the Academy, in an attempt to reach the wider community and to extend its activities, nominated zonal coordinators in its 7 zonal centers covering all the 33 districts of the Telangana for advancement of sciences in the state. The EC in its recent meeting has reconstituted the sectional committees of TAS for the election of fellows, admission of associate fellows and end scientist awards for the year 2024. Coming to this endowment lecture, Srimati Indira Devi Dhanrajagiri Garu, wife of legend poet Sri Guntur Sheshendra Sharma Garu, instituted this in the name of Dr. Manohar V.N. Shirodkar, a renowned virologist of India, in the year 2012. Since 2012 onwards, the Academy has been organizing Dr. M.V.N. Shirodkar Endowment Lecture every year in the month of December or 1 or 2 months this side or that side, depending on the availability of the eminent speaker, as chief guest and deliver lecture. This year, the Academy has invited a renowned medical practitioner, Padma Vibhushan Dr. Nageshwar Reddy Garu, Chairman, Asian Institute of Gastroenterology and AIG Hospitals, Hyderabad, to deliver on artificial intelligence in healthcare. Since 2023 and 24, we have organized several programs. Last year, Dr. Balram Bhargav delivered 11th Shirodkar lecture on 27th December 23. Several programs are organized in schools and colleges in the eve of National Science Day, 28th February 2024, on the theme of indigenous technologies for Viksit Bharat in general and particularly environmental issues and challenges. All the EC members and coordinators participated and gave lectures on this occasion. National Technology Day 2024 was organized on 5th May 2024. Dr. Chaitanya Gangule, former chairman and CEO of NFC Hyderabad, delivered lecture on energy security and environmental protection, the role of nuclear energy. Golden Jubilee celebrations of Smiling Buddha, organized jointly by TAS and NASI on 22nd May 2024. The lecture was delivered by Dr. R. Chidambaram, former chairman of Atomic Energy Commission, on the topic India's nuclear defense readiness and golden deterrence. This year also, several programs organized in schools and colleges on National Science Day on 28th February 2025 on the theme Empowering Indian Youth for Global Leadership in Science and Innovations for Viksit Bharat. In this regard, on behalf of the Executive Council and General Body of TAS, I solicit the generous and valued support of the scientific community of Telangana to make this body more vibrant with its improved activities both in quality and quantity. Thank you very much for giving me the opportunity.
Thank you, sir, for extending such a warm welcome. May I now request Professor C.H. Sanjeev Reddy, Vice Chair President, Telangana Academy of Sciences, to speak about Dr. Manohar V.N. Shirodkar and read out the profile. Thank you.
Good afternoon. On behalf of the Telangana Academy of Sciences and on my own behalf, I invite you all for today's function. On this occasion, the President of Telangana Academy of Sciences, Dr. C.H. Mohan Rao Garu, and today's guest, Dr. D. Nageshwar Reddy Garu, and Secretary of TAS, Professor S. Satyanarayana Garu, and the scientist A.G. Rao Garu, Professor Ramchandra Garu, and other EC members, fellows of the Academy, scientists of IICT, research scholars, and friends. It is my privilege to read out the profile of Manohar V.N. Shirodkar Garu. Dr. Manohar V.N. Shirodkar, MBBS, AB Biology, Doctor of Science Virology, Consulting Virologist, Honorary SMRF, Mumbai, Fellow Maharashtra Academy of Sciences, Funding Fellow, Association of Microbiologists of India, born at Mumbai on December 4th, 1927. He was the son of Padma Vibhushan, the late Dr. V.N. Shirodkar, the world-renowned gynecologist and surgeon. His early education was in Marathi. Later, at the junior Cambridge level, he ranked first in his school and second in the erstwhile Presidency of Bombay at the senior Cambridge examination held in 1944. At the Johns Hopkins University in the USA, he graduated in biology with general honors as a pre-medical student. In America, he was honored through election to Pi Beta Kappa, their oldest and most distinguished society of scholars in the sciences and arts. In 2001, he was awarded the 50-year medallion of the Johns Hopkins University as a member of the class of 1951. He is bio-sketched in the Yale University's School of Medicine 50th reunion album as an alumnus of 50 years standing during 1950-2004. At the Yale University School of Medicine, he began his pre-clinical training. Later, from the GS Medical College, he graduated in the first division with the MBBS degree in 1970. In 2004, he became a 50-year alumnus of the Yale University School of Medicine, and his life sketch appeared in the alum class of 1954, published before the class reunion 2004 held at Yale on June 4th and 5th, 2004. It is alma mater. The Johns Hopkins University, he earned the coveted Doctorate of Science in Virology for original research work, which began and continues in our country even today. Even as a qualified consultant in virology, he has conducted only honorary practice. In 1973, he was invited by the government to head the Department of Virology at the century-old Hopkins Institute. He was consultant in virology with the Shirodkar Memorial Research Foundation, Mumbai. Following retirement as a director, Hopkins Institute, he was appointed Emeritus Medical Scientist by the ICMR New Delhi, and between 1966 and 1988 worked further at the National Institute of Virology, Pune. His major contribution in the indigenously discovered antiviral, anti-cancer biological Christian plasma factor. His work has been extensively quoted in scientific journals in our country and in the USA, UK, Japan, Czechoslovakia, and Malta. Another model developed by him is that of the lager monkey infection with hepatitis B virus. A firm believer in quality rather than quantity, his select handful of MS, MD, and PhD students hold responsible positions not only in India, like the Hopkins Institutes, but also in the USA and Iraq. In 1983, he was elected president, Association of Microbiologists of India, which celebrated its Diamond Jubilee in 1998. In October 1999, he was felicitated for his pioneering plasma factor work by the Association of Teaching Pathologists and Microbiologists at Mumbai in 2004. He was elected founding fellow of the AMI. He was setter trustee of the Dr. V.N. Shirodkar Memorial Research Foundation at Mumbai and currently their consultant virologist. This center works on the clinical aspects of female cancer and on indigenously discovered biological with antiviral and anti-cancer properties. As honorary emeritus scientist, Dr. Shirodkar between 1998 and 2001 researched at the Afghan Institute. He also guided postgraduate students in virology and immunology. Dr. Shirodkar was a fellow of the Maharashtra Academy of Sciences and guided tumor virus research in our country. At Johns Hopkins, he represented the university tennis team and was awarded the letter H in 1948 to 1949. He was a member of the Wellington Sports Club at Mumbai. Thank you, one and all.
Thank you, sir, for throwing light on the profile of a distinguished personality. Now it's time for the presidential remarks by Dr. C.H. Mohan Rao, President, Telangana Academy of Sciences.
Today's chief guest and orator of the 12th Shirodkar Memorial Lecture, Padma Vibhushan Dr. Nageshwar Reddy, Chairman of Asian Institute of Gastroenterology, and our guest of honor, Dr. A.G. Rao, Chief Scientist, IICT. Dr. Srinivas Reddy, Director, IICT, unexpectedly had to go to Delhi this morning, and Dr. A.G. Rao has kindly agreed to take his place in a very short notice. Thank you, sir. Dr. Srinivas Reddy has been extending all his support to all activities of the Academy. Likewise, Dr. Vinay Kumar Nandikuri, Director, CCMB, and Dr. Prakash, Director, NGRI, all three laboratories were extending full support to Telangana Academy activities. And Academy is really thankful to them. Professor Satyanarayana, General Secretary of the Telangana Academy of Sciences and former Vice Chancellor of Usman University. Professor Sanjeev Reddy, Vice President of Telangana Academy of Sciences and former Professor of Chemistry at Kakatiya University. Professor A. Ramchandraya, Editor of Publications, Telangana Academy of Sciences and former Professor of Chemistry at NIT Warangal. Dr. Shasikiran, member of Shirodkar Memorial Endowment Committee and also former Director of National Institute of Nutrition. Executive Council members of Telangana Academy of Sciences. I see many senior colleagues in the audience. Dr. Amit Chattopadhyaya, Bhatnagar Fellow at CCMB, and many other, Dr. Madhav Bamji, and many people that I see here in the audience. I'm very pleased to see all of them. And my large number of colleagues from CCMB, IICT, NGRI, and young students from different medical colleges, press, media personnel, and ladies and gentlemen. Before we proceed further with the academic program, scheduled program, I'm happy to make an announcement that one of our fellow of the Academy, Professor Prakash Babu, has been chosen to lead the Pondicherry Central University as a Vice Chancellor. He's also chosen to be the Vice Chancellor of Yogi Vemana University, but obviously I believe he is going to be Vice Chancellor of Pondicherry University. Now, on behalf of the Academy, may I ask our Vice President, Sanjeev Reddy, to felicitate Prakash Babu with a flower bouquet. Prakash Babu, please. Thank you, Professor Sanjeev Reddy and Professor Prakash Babu. We are grateful to Dr. Nageshwar Reddy for kindly accepting our invitation. Thank you, sir. Shirodkar Memorial Lectures are becoming very popular, and this is the 12th lecture. And many eminent speakers have given this lecture. Some of you might have attended some of those lectures. They included Fellows of Royal Society and Nobel Prize winners and Director Generals of ICMR and many other major organizations of our country. All this became possible because of the generous endowment instituted by Rajkumari Indira Devi Dhanrajkar. She has entrusted this activity to a 3-membered committee. Indira Devi herself, myself, and Dr. Seshikiran. 3 of us are responsible for selecting the speaker every year and organizing this annual lecture at one of the institutes. Rajkumari Indira Devi is the eldest daughter of Raja Dhanrajgir Bahadur and Rani Vijay Raje Parmila Devi. Rajkumari Indira Devi is the wife of legendary poet Guntur Sheshan Sharma. Some of you might have heard his name. He has written a large number of books and songs, Telugu movie songs also. He was called as a Yuga Kavi, and he also received a Sahitya Academy Award. And one of his well-known book is Nadesham Na Prajalu. And it is translated into many other languages as well. Indira Devi herself is a multifaceted, talented person, and she writes in English, Urdu, and Hindi. And in addition, she also paints. And she has published several books. One of them is Partings of Mimosa, a long poem. And this poem was published in the magazine from University of Wisconsin. And other works include Memories of Deccan, Return of Eternity, and things like that. So she wrote quite a few. And she also wrote an autobiography in Urdu titled Kah Kashan. We are thankful to her for a generous contribution which made these eminent lectures possible year after year for now the 12th year. She has been attending all these lectures. Every year she was coming and very patiently sitting through. She was quite a senior lady, past 90 years. She was sitting on the dais and listening to lectures and also discussing with the speaker after the lectures. This year she could not come because she is indisposed, and we all wish her speedy recovery. Padma Bhushan Dr. Nageshwar Reddy is a global leader in healthcare. He is a well-known gastroenterologist, scientist, and an institution builder. Anybody who has seen AIG hospitals would wonder that such a massive building with such a sophisticated facilities can be built in India. We are fortunate that he has kindly accepted our invitation to be with us today. My colleague, Dr. Seshikiran, will formally introduce the speaker with all his accomplishments and accolades he will list out. But I'll just say a few words, being aware of him or known him for a few years now. Little over 2 decades ago, I met him for the first time at his AIG Somajiguda hospital. Current hospital is in Gachibowli. His earlier hospital was in Somajiguda. I visited him at that hospital. There were very long queues. The people were waiting for him quite. And of course, I could get through by connections. so when I walked to him and I spoke to him and I wondered how come he handles this many people a day. And he says he starts early in the morning before sunrise, maybe around 6 o'clock, and goes up to 11:30, 12 in the night. And in that hall where I was there was only one bed for the patient to sleep, and he was standing. So I was surprised at his stamina for working whole night, and I asked him how come he manages that and we can't do that. Then he said, any day he will work out. Workout is definite. Even at 11:30 in the night, he will go for workout. He said that because when he asked me that I should work out, then I told him I have little less time. I'm not able to find. Then he said he works up to 11 o'clock, 11:30, then he goes for gym and then he sleeps. Okay. Then he made us wonder that, okay, we should also start doing such an activity, and we are indeed pleased that, I actually got inspired with those words. That was very interesting. Then since then we have had many occasions where we have interacted. As a matter of fact, his team was collaborating with CCMB extensively. Dr. Chandak's group, Chandak is not here at the moment, but Dr. Chandak's group has been collaborating with him extensively. There were many publications, very important landmark publications. We had a press conferences together where we discussed about the achievements. it's very nice that he has accepted to come to us today. Dr. Nageswar Reddy is a third generation doctor in their family. His father, his grandfather, maternal uncle and maternal grandfather all were medical doctors. Okay? And his maternal grandfather, apparently, Dr. Govinda Reddy, was a professor of pathology and was a good friend of Scottish physician Alexander Fleming. I'm sure all of you know Alexander Fleming. So obviously he grew up in the ambience of medical science. So I understand that as a child he was very curious, and apparently his curiosity led to burning down of a garage. He was trying to see how petrol burns, and he burned the garage in the process. But his innovative mind continued after that, of course, and his curious mind led to many medical inventions. One of such invention is the Nagi stent. Okay. Nagi stent is, of course, I just said Nag stent because we have another distinguished doctor, Dr. G. Nageshwar Rao. Nageshwar Rao is called Nag, and Nageshwar Reddy is called Nagi for some reason. So there is a stent named after him, the Nagi stent. Nagi stent is biflagellant metallic stent used for drainage of pancreatic pseudocysts. Okay. This part is medical part. The other part we know is that it is made up of nickel, titanium. Nickel and titanium are combined with that, and it is made in a national novel ordnance laboratory. That's why it's called NITINOL, nitinol. That's the name of it. Specialty of nitinol is that it's a memory metal. In the sense, you make one shape at one temperature and change the temperature, do whatever you want. If you bring back the temperature, it will attain the same shape, which remembers the shape. So that can be used in a drain system, because you make a small drain, push it in the body, and that opens at 37 degrees temperature. It opens and attains its own shape and works like a drain. So that's what was designed and manufactured by a Korean company. That is called Nagi stent. Okay. As I mentioned, of course, Dr. Shashikaran will formally introduce Nageshwar Reddy and give you all his list of achievements. Dr. Reddy chose to talk to us about artificial intelligence today. Artificial intelligence in healthcare today, that's his main domain. Artificial intelligence is actually becoming increasingly important in our every walk of life. But AI, artificial intelligence, as we now talk about, is not new. It was there for a very long time. In 1956, John McCarthy used the word first time, saying that artificial intelligence. Okay? That is going on for the last 70 years, not now. His conjecture at that time was that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. That's what he thought. Understanding or learning can be described very precisely so that a machine can simulate it. That's what is artificial intelligence. That's what he thought it is possible in 1956. Okay. Then, of course, lots of things have come up. We all talk about playing chess. There are computers which play chess and then defeat world players. But that's not any artificial intelligence. It doesn't need any artificial. It only needs computation power. You need to look for all the possible moves, and you need a very high computing power for that. That's only computation power, not very intelligent. But small things are very difficult. For example, if you make a robot to pick up a cup by a robot is more difficult than playing a chess. The reason is, if you want to ask the robot to pick up a cup, robot can use with the camera, it's a digital camera, it'll see a cup. Now cup is too far away or cup is near. The small size will change. So its image of cup will not match. Okay? Image of cup, what is there in the memory, will not match with the cup is going farther, neither, smallness. So you need a size invariance. Something if the handle of a cup is one side or other side, again it will be different. So you need a shape invariance. Shape invariance, size invariance is all to be built into artificial intelligence. All this is done. Now AI is available for every one of us to use. This technology has developed so well that everybody is now able to use this very nicely. But today AI is now largely works on LLM. LLM is large language models. Large language models actually pick up whatever knowledge is available in the internet and has an algorithm to precisely predict the next word. By predicting the next word, it is going to give you an answer. Very interesting question people ask is, when AI answers you, does it feel it? Does it have a conscience? For example, if you ask a very bad question, your system got angry, can the AI system get angry? AI system can give you answer, but does it get angry? Does it feel happy? So the consciousness is not there, so does it make sense? We don't know yet, but it will be a guide. AI will be a guide, but it should never be taken as a boss. But main two things of the AI are that autonomy and adaptivity. AI is autonomous. It will do everything by itself. Autonomy is there, and adaptivity. It will adapt to any condition. It will improve. So key features of AI is autonomy and adaptivity. Although they are key features, they are also dangerous features. If it becomes autonomous, we should be worried. But AI in biology is catching up very well. Very fast growing AI in biology. AI in medical imaging processing, we can see that. AI in drug discovery, we can see that. There are a large number of things that AI is developing. Dr. Nagesh Reddy has chosen to speak on artificial intelligence, and he has been quick in adopting AI in medical practices in healthcare sector. So he has established a world-class facility at AIG. AIG is the largest gastroenterology hospital in the world. Okay, we should be proud of that. And patients from different parts of the world come for treatment. And I myself have seen there is a separate cell for facilitating international patients. So international patients come there, for them there is another cell to take care of them. In one of the interviews that he has given, he has mentioned that he lives by 3H principle. The 3H principle is humanity, honesty, and hard work. We see that successful in AIG hospital, and we see. We are indeed pleased that he has agreed to give the 12th MVN Shirodkar Memorial Lecture. Now India is a prominent player in science, in space technology, digital payment, and software development. It is in the line for quantum computing as well. I sincerely hope that our country will become a significant force in the field of artificial intelligence. Jai Hind.
Thank you, sir. May I now request our guest of honor, Dr. A.G. Rao, Chief Scientist, CSIR IICT, to deliver his message.
Namaste to all of you. So, it is that our director is suddenly out of station. I could take this place. It is a great honor for me to sit beside such legendary personalities. So, respected Dr. Mohan Rao Garu, Professor Satyanarayana Garu, Professor Sanjeev Reddy Garu, Dr. Shashikiran Garu, Dr. Nagesh Reddy Garu, and Professor Ramachandra Garu, and ladies and gentlemen, students and research scholars in the audience. Really, it is a great pleasure for me to really sit beside such a great legendary personality. I read a story, it must be definitely true, way back in, I think, early 80s or late 70s, when Amitabh Bachchan met with an accident in Coolie film, while shooting for Coolie, he went and joined US for treatment. Then the doctor at the US told him, why you came all the way to US? Because the best gastroenterologist is available in India, that too in Hyderabad. That is Dr. Nagesh Reddy Garu. So straight away he came to Hyderabad and he became a patient of Dr. Nagesh Reddy Garu. So that is such a personality. The world over is very renowned actually. In fact, actually, I am also one of his patients long back, 15 years back. I am diagnosed with hepatitis positive. So our doctor dispensary told me definitely I should meet Dr. Nagesh Reddy Garu. So I went Somajigoda and got tested everything. Like Mohan Rao Garu had a lot of connections to take his appointment, but I do not have any connections. I simply sat before a PA. I told him, sir, I definitely want to meet Dr. Nagesh Reddy Garu because this is hepatitis positive for me. So what will happen to my life, I had to know from him directly. Then next day morning, 6 o'clock, he gave an appointment. So I went 6 o'clock. Then he told me 15 days, use this tablet. Don't eat outside much. Take care of your food habits. That is the only suggestion. And he is such a good doctor that still I am alive. So very thankfully, sir, actually. And really today, they are organizing Telangana Academy of Sciences lecture, Dr. V.N. Shirodkar Memorial Lecture, and such a legendary personality is giving lecture. In fact, actually, the advertisement has not gone well, I think. Otherwise, the auditorium would have been full, I think, flooded with people actually. And that too, they made the word artificial intelligence. That's the people little confused, I think. Simply something, different generic topic would have been there, the auditorium would have been flooded with people like anything. In fact, actually, whenever he gives lectures, the Hindu paper publishes. I definitely read that article, Dr. Nagesh Reddy garu, wherever he gives lectures. The Hindu, very nice articles, he publishes complete detailed lecture. So such a legendary personality. And the place at which this lecture is being organized at IICT, which plays significant role in healthcare through its research, development and collaborations, focusing on drug discovery, synthesis of APIs and technology transfer, disease prevention and treatment. All of you know that CSIR IICT played a key role in the development of Covaxin, the country's first indigenous vaccine, focusing on improving the efficiency of vaccine through adjuvant systems. The institute developed a cost-effective process using locally available chemicals to synthesize the active pharmaceutical ingredient for manufacturing favipiravir. So therefore, this is the right place for a right person in a memory of a great personality. So all together really happened very nicely. I sincerely thank Telangana Academy of Sciences for making this as a venue actually, because most of our staff and students, research scholars are getting benefit from it. So I sincerely welcome to IICT all of you, and I am very eager to listen to the lecture of Dr. Reddy garu. Thank you so much.
Thank you, sir, for the insightful message. Now I request Dr. B. Shashikiran, former Director, NIN, Hyderabad, to introduce the speaker of the day.
So all the respected dignitaries on the dais and the speaker for today, and all of you in the audience who found the time to come and be present and listen to this talk, thank you all. Before I formally introduce Dr. Nagesh Reddy, a little bit of informal words that I came to know about Dr. Nagesh Reddy through his father, Dr. D. Bhaskar Reddy. Dr. D. Bhaskar Reddy was the former Vice Chancellor of Nagarjuna University, Guntur, and he was also the Director of Health Services of the undivided Andhra Pradesh at that time. He was a very brilliant pathologist and a very able administrator. But he had one quality which most of us have lost, and that is the ability to laugh and the ability to make others laugh. He was a person of tremendous sense of humor, and whether he was making a scientific presentation or he was scolding somebody, the other party always used to be laughing. So that was the personality of Dr. D. Bhaskar Reddy, and it is unique that even on the day he passed away, he died with a smile on his face. So I think, Dr. Nagesh Reddy, you're very fortunate to have a father like Dr. D. Bhaskar Reddy. And then, of course, now coming to Dr. Nagesh Reddy. He has already been mentioned by Dr. Mohan Rao. He is the chairman and the managing director of the Asian Institute of Gastroenterology, which is considered one of the largest gastroenterology hospitals in the world. The honors and awards go into several pages. But to be brief, he has won every possible award a medical scientist can get in this country. That is, he got the BC Roy Award, he got the Padma Shri, the Padma Bhushan, and this year he also got Padma Vibhushan. We are also proud of him because he's a fellow of our academy as well, and also the fellow of the National Academy of Medical Sciences. He's got the Master Endoscopic Award from the American Society of Gastrointestinal Endoscopy in 2009, and the International Leadership Award in the same society in 2011. Master of World Gastroenterology by the World Gastroenterology Organization 2014, and the American Association of Advancement of Science, and he's a fellow of the American Gastroenterologists Association and the American Society of Gastrointestinal Endoscopy President's Award. And he has also won the prestigious Rudolf Schindler Award for Gastrointestinal Endoscopy by the American Gastrointestinal Endoscopic Society, which only 2 non-Americans have been given this award till date. He is one among them. And he has also obtained the award from the Johns Hopkins University for the prestigious Captain's Chair in 2024. So we look forward to Dr. Reddy's talk on artificial intelligence in healthcare. I'm sure when he finally concludes, he'll probably say artificial intelligence can never equal human intelligence. You're welcome, sir.
Thank you, sir. It is such a delight to get to know the profile of such an eminent personality. Let us now listen to the most awaited 12th Dr. Manohar V.N. Shirodkar Memorial Lecture on Artificial Intelligence in Healthcare by Dr. D. Nageshwar Reddy Garu, Chairman, Asian Institute of Gastroenterology and AIG Hospital, Hyderabad.
Thank you very much, Matt. I'd like to thank the Telangana Academy of Medical Science for Telangana Academy of Sciences for giving me this honor of this very prestigious Manohar Shirodkar Award. In fact, can you hear me there? Can you hear me? I got a collar mic, okay. Not the end, I'm just, okay. So I'd like to thank especially Professor Mohan Rao for giving this, in fact selecting me for this. I've known him for many, many years now. A very simple scientist with profound thinking. In fact, at the CCMB we did many things together, including the pancreatic genetics, where we discovered for the first time what causes chronic pancreatitis in our country. And this has been now taken all over the world as a fundamental research point. And similarly, Professor Shashikaran is almost like a family. He is a guide and philosopher to our institute now. He's the chair of ethical committee. And whenever we are going something wrong in research, he scolds us and keeps us in tune. So I've chosen this artificial intelligence in healthcare mainly because, as you can see, there's a huge noise all over the country, all over the world on artificial intelligence. And it's believed that of all the specialties, artificial intelligence is going to impact the world in healthcare, agriculture and education. These are the three areas is going to dramatically change how world progresses. About 5 years back, I was a total disbeliever in artificial intelligence. I thought medical care is empathy, natural intelligence, looking after our patients well. But in the last 2 years, I became a total convert. I think somewhere we have to use artificial intelligence to enhance medical care. So let me start first with a disclaimer that I'm not an AI scientist. I can't make algorithms and all that. I can just use LLMs and other things for medicine, and I'm going to show you how at AIG we're going to transform healthcare using AI. In fact, this is the first model in the country of how healthcare is going to transform medical care. So when I asked to give this talk, the problem as everybody said, the time was very less, you had to collect your thoughts. So what I did is, I went to ChatGPT and I asked ChatGPT, I have to give a 30-minute presentation on AI healthcare, can you help me? And look what it did. It said, let's break it down, the title, the introduction, 2-3 minutes briefly, and then the basics of AI in healthcare, the key applications, medical imaging, diagnostic case studies, predictive analysis, personalized medicine. So this is going to be my summary of what I'm going to talk, everything then. And finally, ChatGPT asked me, should I make your slides also? I said, no, I'll make it myself. So traditional patient care was like this. Traditional patient care was empathy, natural intelligence, and how we look after our patients. In fact, this is a 1857 painting on medicine. This is a very famous artist, and the artist is seen in the background. There is child was dying of a diarrheal illness. The doctor, country doctor at that time didn't have magic pills, didn't have imaging, anything. But he drew this painting showing the empathy, how the empathy a doctor has on a patient. And this empathy was enough. Unfortunately, in modern medicine, we are losing this empathy because we have so many investigations, so many pills and so on, but empathy is a very important aspect. So, can artificial intelligence replace this? And as Dr. Shashikaran rightly said, maybe it cannot, but maybe it can, we'll see. So now, medicine is becoming a lot of artificial intelligence added on. It's just not natural intelligence, but there's something like artificial intelligence coming in. So let me just briefly, for those who are not very aware of how the whole concept evolved, the concept of artificial intelligence came by Alan Turing. Alan Turing was a very famous British mathematician who in the Second World War actually used the first AI technology to decipher the codes that were occurring between the German ships around Britain. And he could break the code using AI. This was the first usage. In fact, now there is a prize called the Alan Turing Prize, which is a prize given to computer scientists, like a Nobel Prize. There's no Nobel Prize for computer scientists, it's Alan Turing Prize. One Indian also got the Alan Turing Prize, Professor Raj Reddy from Carnegie Mellon. So this is started how? 1956, as Professor Mohan Rao said, John McCarthy coined the term artificial intelligence. Now what he meant at that time was artificial intelligence was a machine having the human intelligence. That was a broad definition. It was not very clear. Even now it's not very clear. Even now when you ask what is artificial intelligence, you get several definitions for this. From 1950s to 1970s, there was a winter of knowledge. Nothing happened in artificial intelligence. Nobody cared about it. It was only in 1980s when machine learning came that people started now saying that you can actually teach a machine how to think, how to decide on those things. So that's how it started. But the most important advance in artificial intelligence came in 2010 when this concept of deep learning came. Deep learning is a concept that when you put in knowledge into a machine from several aspects, it synthesizes knowledge and comes out with output which is very intelligent. This is deep learning or machine learning. There are several aspects of this. So you can see that starting with the initial concepts, you have machine learning, which is very basic, and of course you have deep learning, which is the breakthrough that occurred in artificial intelligence. So again, for those who don't really know too much about it, it's a very simple concept that I'm looking for. When you say artificial intelligence, they are what are called foundational models. There are three foundational models that students should remember. The first foundational model is called language models. The one with what we use, Chat GPT, is this language model. It's a large language model. They can also be small language model, but this is a large language model. Similarly, we have what is called the computer vision model. Computer vision is that in medicine, for example, the machine sees a lesion and says, this is cancer, this is not cancer at all. This is all computer. So it learns through being fed with the data, it can differentiate cancer from non-cancer and things like that. And the third model is audio, that is the natural language processing, NLP model. Natural, that is you talk and artificial intelligence can pick up, synthesize your talk and put it in different form. These are the three foundation models used in many areas, but most often in healthcare. So what is the application? Broadly, artificial intelligence is used for diagnostic and image analysis, for drug discovery and development, and this is very, very important. Some years back, to make a vaccine, to discover a new drug, it took about 20 years. So the first drug is made, a lot of intelligence going into trying to see where it acts, background knowledge is taken, then started testing in animals, cell cultures, and finally. So from the beginning to the end, it takes about 20 to 25 years minimum, and this was supposed to be very fast. Now with artificial intelligence, drug discovery is taking 2 years, 1/10 the time. Because the AI immediately works out so many models, tells you that this is an enzyme abnormality in the patient, what is helpful? AI will tell you immediately in a week's time, this is helpful. You make on AI models of the drug and see how it reacts with receptors. Again, couple of weeks. And testing, animal testing is only remaining, and now we are also improving on that with cell cultures and all that. Within about 2 years, now drugs. Vaccines, just imagine how vaccines are going to, any new epidemic that comes, within about a month's time we can get a new vaccine now because of AI. So AI is dramatically affecting that and several other areas that's affecting. This is not coming. Okay. So the various specialties in medicine where AI has been helpful is in, of course, I'll show you some examples, radiology, imaging, and so on. What I'm going to do predominantly from now on is to show you what we are doing at AIG and how we are using artificial intelligence, because that will be more useful to you. So for the clinician, AI helps in rapid and accurate diagnosis. For the health system, it improves the efficiency of the whole health system. And for the patient, of course, personalized health, it promotes. So many of the young doctors, when we started the AI department in a hospital about 2 years back, many of the young doctors came to me and told me they were worried. They said, now is AI going to replace us? Is AI going to replace doctors? I tell them one thing, AI is not going to replace doctors. But doctors who know AI are going to replace doctors who don't know AI. That is going to be the future. It's going to be very important. That's why any young doctors here, go into AI, learn the fundamentals of AI, because that is going to be the future of medicine in addition to what you practice. So if you look at all the uses, let me just show you a few. Health services management, how it helps, predictive medicine, patient data, and clinical decision. Again, these are all examples of what we are doing at AIG. Many more things can happen in different other hospitals all over the world, but I think this is something which we have started doing very fast. So health services management. So AI is now, we use it very often in the hospital for optimizing operational efficiencies, and I'll show you examples. For predicting where we should put our resources allocation. One area, patient rush is more, this department is doing well, we put more into that area. For detecting frauds and compliance is very common in hospital setup. Suddenly the pharmacy, valuable drugs disappear. And now we're able to track it with AI, what's happening. And integration of services across different courses. And let me show you an example. So this is a robotic system that we made. This is called MIRA, Medical Information Robot of AIG. And let me just...
Hello, everyone. I am Mira, the medical information robot at AIG Hospitals. I am your future healthcare companion and here to change the way we think about healthcare. I have been meticulously designed to assist doctors, empower nurses, and most importantly, ensure that patients receive information in a faster and better way. I will assist patients and healthcare professionals, but never replace them. My goal is to enhance patient experience with human oversight and in the future, with appropriate training, my role may increase for evidence-based circumstantial requirements. I look forward to learning from the clinicians' experiences to continuously enhance my skills in the field of gastroenterology and other specialties.
So we created this MIRA for the reason that when we see patients, many patients, after I see them, ask me a lot of questions. Doctor, when should I take this pill? 1 hour after food, before food? What are the potential complications of this tablet? What diet should I use? When should I come? So among the 20 minutes consultation, I spend or waste about 10 minutes in this. So we thought, can't we replace this with somebody who can, based upon AI, do this? So we started this MIRA. So MIRA is kept outside our outpatient department. After I finish talking to the patient, any doubts, I'll tell you, go and ask MIRA. Initially, the patients were a little, wondering what happened. So now what happens is, now patients, after I finish, tell me, no, you don't explain, doctor, I'll go to MIRA and ask. Because not only MIRA is probably more knowledgeable, but better looking than me, and they want to go to MIRA. So now slowly we're also using MIRA for postgraduate education. MIRA has a huge amount of knowledge. So an ERCP is done. Now patient will, that's a procedure we do endoscopically. Patient will go and ask MIRA, what are the complications of ERCP? MIRA also has a track record of all our doctors who have done this operation in the hospital, so that it can ask MIRA which doctor is best for ERCP. So MIRA will tell you all that. And also our junior doctors are now starting to interact with MIRA. Junior doctors will ask what are the indications for this endoscopy. MIRA will able to tell you. So how much more we feed in MIRA, it becomes better. MIRA is an information system. It's a chat GPT, large language model, but it's done in such a way that it attracts people to come and interact with MIRA. So we have found this to be extremely useful now in our practice. Similarly, this is another very important thing that our AI engineers made. Incidentally, what we did was to create an AI department. We got about 40 engineers from Google, Microsoft, all the places, very bright people, and created this. We are the only hospital in the country now having such large group of artificial engineering department people in our center. Yeah. So it's very expensive. Actually, engineers are more costly than doctors. We had to pay them more. And the electricity that it consumes, the AI department, is much higher than CAT scans or MRIs. So we thought, is it worth it, so costly? But we realized we are saving efficiency, we are saving money, and so on. So this is an example of that. This is called iSave. Now what happens is, let me give a brief background. In a hospital like ours, where 1,000 beds are there, 1,000 beds, there are very sick patients in all the beds. There are very sick patients in intensive care, which are looked after by all our intensive care specialists continuously monitor. But rest of the 900 or 850 patients are in the wards or in the hospital rooms where continuous monitoring is not always possible. We have a nurse and doctor for a particular group of patients. Now, these patients, some of them are sick and suddenly they'll crash, they'll develop a cardiac arrest. So what happens is then immediately a code blue is made in the hospital. Code blue, they announce throughout the hospital, there's a team of code blue, cardiologists, anesthetists and so on, who will rush to the patient's bedside and revive the patient. On average, we are getting about 6 code blues a day. This is for any hospital in the world. Any big hospital will have 6-7 code blues a day. Out of the 6 patients, 3 of them are so bad that even the code blue teams within 4 hours, you must reach within 4 minutes. Even if they reach within 4 minutes, they are not able to save them. So 50% of code blues will die. So we thought, can we change this? So we created what is called ISAVE. What we found is that there are 7 vital parameters: blood pressure, oxygen saturation, pulse rate, breathing rate, all those things. There are 7 parameters. If any patient reaches 5 parameters, it is likely that in the next 1 hour or 2 hours he'll go into code blue. So we said we'll do one thing. We'll have an AI algorithm where any patient, any room reaching these 5 parameters, because all these parameters are normally recorded by sister, it's common, reaches these 5 parameters, immediately our medical emergency team, MET team, is informed. The medical emergency team goes there and then revives the patient even before it goes into cardiac arrest. So we implemented this 6 months back after our engineers drove this algorithm. In the last 6 months, not a single code blue has come. Every single patient going to code blue has been detected before, which means that every day in the hospital we are saving 3 lives. And probably much more in terms of economy and so on. So this is a classic example of how AI is used to do this. Then another very interesting thing I'll tell you is that when a patient, we do about 1,500 surgeries a month, 50 a day. So every patient is going for surgery is asked to get a pre-anesthetic checkup. So when you go for a pre-anesthetic checkup, we have found that 20% of the patients are not coming back for surgery. So we asked our AI, what's happening? The AI actually drew a map of each patient. When he's asked to come, go for a pre-anesthetic, what happens? And you can see how the patient, they go from internal medicine, pulmonology, cardiology, x-rays, everywhere to get a clearance from them. And ultimately it drew what is called the spaghetti graph, the patients going to so many. Every patient has 17 stations to go before they finally come back for surgery. And 20% of the patients were not coming back because they get tired so much. So what is the solution? We asked the AI solution. AI said, put all these facilities in one tower, one place where patients can come. I said that simple thinking, why can't normal people do it? Do you require AI to think about that? No, but do you require AI? Because to establish a facility like this in a single tower will require a lot of additional staff, anesthetists, cardiologists, radio, everybody. The cost involved, the infrastructure involved, putting extra machines involved. So I said, looks like we have to spend much more. Is it? Then AI came with solution. It calculated how many dropouts will become patients again, what is the comfort, what is the efficiency level, what is the image that happens. And he told us clearly that your dropout will come to only 1%, that your efficiency will improve and so on. Said, okay, we created this pre-surgery lounge, another tower, where patients will come in the morning, 9 o'clock, go through all the things in about 1 hour's time, have a nice cup of coffee and cookie, and then go back. Very nice experience. And as AI predicted, 99.9% of the patients are coming back for surgery. And we not only increase their efficiency image, but also the money saved, coming back for surgery is equivalent to putting up a more than good tower. So it's another classic example of how AI is used for operations. The third thing is this, we have, as I think mentioned earlier, that we have the world's largest endoscopy setup, 1 lakh square feet. My passion is endoscopy, so we set it up saying we should be the best in the world. We are best in the world. We have about 30 endoscopy rooms, 700 to 800 procedures are done every day, endoscopic surgeries. The average big hospitals all over the world would do 80 to 100. We do 700 to 800. It's a big complex. If you go into this complex, you get lost. Patients come, they go inside. Nobody knows which room, which operation theater patient is, which patient finished, the outside all the attendants are anxious waiting because even the nursing staff and doctors can't tell them which he's gone into which operation there when he's coming out and all. So I thought this has to be made more efficient. We made this system where we made a tracking system, endoscopic tracking system, where all the patients were given this, you see this tracers, RF bands. The RF, throughout the rooms we put RFs there, and you can see the patient movement is monitored completely, which patient is going to which room, and so on. And we have a big data chart there, which comes into my phone, cell phone all the time, telling me which patient is where, how many registrations and how many completed, what is in progress, what is the total average time. Total average time in a good endoscopy unit should be less than 2 hours. Very, very few units in the large units in the world have this. We are able to achieve this 1 hour 30 minutes because of this. Because I know that if the patient is waiting too much in the pre-procedure room, something is wrong, I send doctors there. If the procedure is taking a long time, something is happening in this theater, I send the doctors there. So using this efficiency model, we have now become the most efficient endoscopy unit in the world. In fact, the Harvard Business Review is writing a review on this when they watch this. And again, it's because of AI, which has... Now coming to predictive medicine, this is also very interesting. With AI, you can actually early disease detection, risk stratification, a lot of things can be done. And most important now, epidemic outbreaks can be predicted. Unfortunately, 5 years back, when COVID came, we didn't have this, nowhere in the world. But now we have developed this epidemic prediction system. Recently, about 6 months back, there was an epidemic in China. Maybe it would have become another COVID, another virus which was there. But because they had AI, at that point of time they applied, they could contain the epidemic within that city within a few days' time. It never came out. We never had another COVID. This again is going to be a very important thing, important role the AI is going to play in future world, predicting epidemics so that we don't get into a situation that we got in earlier. And the predictive drugs medicine is also going to be very important. All of us as medical students here realize we read textbooks. It says give 1 tablet once a day, 1 tablet twice a day, 1 injection twice a day and so on. That's the standard teaching. But unfortunately what is not figured into it is a huge biological variation that occurs in individuals. Every individual metabolizes the tablet in a different way. We have some data on this tablet. Sometimes certain individuals don't, they require only less dose and so on. But we don't have large data. So what we did is that every patient coming into AIG hospital who require more than 4 drugs, diabetic, hypertensive, cardiac disease and so on, require more products, we did a basic genomic, pharmacogenomics called. Pharmacogenomics of pathway of that drug. So drug comes in and then what we did is we did a AI algorithm integration of seeing that if the 4 drugs are taken, how they interact with each other. And we found that 40% of the patients, the drug doses had to be changed, different. Instead of 1 tablet a day, some patients require 2 tablets a day, some patients require 1 tablet once a day. And this pharmacogenomics, now we have made it like mandatory. All the patients get a pharmacogenomics before they start taking tablets, done only once in lifetime because that is the genome of the patient. And then you can change your drug based on that. It helped us now to be very efficient in terms of how we dose our patients. Unfortunately, again, this is a practice not adapted anywhere, which we are trying to encourage. We just send a paper to New England Journal, and hopefully this will become a practice all over the world now. And look at this. This is again very interesting. This is a fatty liver, non-alcoholic fatty liver disease, which is very common. 30% of Indians have non-alcoholic fatty liver disease, which means maybe about 60 people in this hall, we actually have non-alcoholic, yet you don't know. Unfortunately, this non-alcoholic fatty liver disease will lead into fibrosis, cirrhosis, and even hepatocellular carcinoma. Highest level of hepatocellular carcinoma in India, in the world, is from India. It's the capital of HCC. This is very common. How do you diagnose it? The best way to diagnose it is use what is called a fibroscan. We have a machine called fibroscan, like a CT scan. We put on the liver, it will tell us this is the fibrosis, this is the fat in the liver. Unfortunately, this machine costs about 1.5 to 2 crores. And each test will cost about 5 to 10,000 rupees for the patient. So it can't be applied everywhere. We do it commonly in a hospital. You can't go to a rural area and do this. But you know that incidence of fatty liver in India, especially rural areas also, is very high. So we thought, can we evolve a simpler method by an AI algorithm to find out the fatty liver? And we did this NAR prediction dashboard and see what happens in this. What we did was we took 4 blood parameters and made an algorithm to see if it can predict just simple blood tests. We can predict the same thing. And these are all the simple blood tests that are done. And based on this blood test, we can actually predict what is the FibroScan result. So we see that the blood test algorithm is saying a FibroScan is 270 fat, 6.8 of the, this is actual FibroScan figure, 277, 6.2. And look at when we put our algorithm made from these 4 blood tests beside this, it's almost same, 2.7, 6.8. So a simple blood test available anywhere, even in the small villages, costing about 200 rupees, can predict the same thing using algorithm exactly like a 2 crore machine costing 10,000 rupees. So this, now we are patenting this and then we want to give it over to other places to use. So this is something again very remarkable. Then the patient, the other area of course is patient, how we actually diagnose when is a disease. Again I'll show you some examples. Before I actually go into the example, another thing I want to tell you what doctors do wrong. Traditional medicine, and I think as Dr. Shishkiran pointed out earlier, was seeing the patient, empathy for the patient, I palpate the patient, I write down the note, get a diagnosis. This changed in the last few years because we all want electronic medical records. We want all the records of the patient. All over the Western world, now in India also it has come. That whenever the patient came, I spent 20 minutes with him. Out of the 20 minutes, 18 minutes is looking into the computer, typing, age, sex, this thing, father's name, this one, that one, what is here. That is the time I spend all this time with him. 2 minutes only I'm seeing the patient eye to eye. But we know that medicine is different. In medicine, true medicine, you have to look at the patient, talk to the patient, see him eye to eye, and then a diagnosis not only is made, but patient is comfortable, gets cured. But we can't do this in the current, because of the EMR system. So what we now created using AI algorithm is this. It's called PRISM, Prescription Recorder Intelligent Summary Maker. If the patient has come to me, I have a computer, but I don't type to it. Just see what.
क्या तकलीफ है राजेश? सर पेट में बहुत दर्द हो रहा है सर एंड इधर बहुत क्या पेन आ रहा है सर। ये कितने दिन से हो रहा है? सर 2-3 मंथ से हो रहा है सर। 2-3 मंथ? यस सर। और जो जलन हो रहा है ज्यादा छाती में? यस सर ज्यादा हो रहा है सर। नाजिया या वॉमिटिंग है? यस सर। भूख कैसा अच्छा है? यस सर। भूख ठीक है? यस सर। और मोशंस का कोई प्रॉब्लम है क्या? मोशंस नॉर्मल सर। स्टूल्स नॉर्मल है? यस सर। कुछ प्रॉब्लम्स है पास्ट में कुछ डायबिटीज या बीपी का तो नहीं है? नो सर। हाइपरटेंशन? नो सर। ये प्रॉब्लम जो है ना वो आपको कुछ पेरेंट्स को भी है? है सर, मेरे पेरेंट्स को भी है सर। पेरेंट्स को भी अल्सर था? फादर को अल्सर? अल्सर। So Rajesh, your diagnosis looks like peptic ulcer. So we'll have to do endoscopy and ultrasound. For that I'll start your medication, pantoprazole 40 mg daily. Once we do endoscopy, we'll give the pilot.
So I just tap after everything is over on the computer and I get the whole thing in not only what we talk, but in a segmented form. Present history, past history, allergies, family history, diagnosis, everything comes. I just make a printout and everything is there. But all the time I'm talking to the patient. I'm not looking at the computer at all. And the good thing about it is that it takes 4 languages. So you see, I talked in English, I talked in Hindi, it takes in. And the better thing about it is if I do any gossip, have you seen Pushpa movie recently? It doesn't come in. It filters out all the gossip. Only the medical terminology is taken in. So that protects our doctor sometimes. So this is something again which is transforming. In fact, the advantage in India is we have a large number of patients. We have already tested this in 30,000 patients. Next 3 months we are doing it in 100,000 patients. And once this is done, as a complement thing, we want to give it to all the hospitals free of cost all over the country. Can you imagine if everybody uses it as the same EMR, they become interoperable and everybody can speak in the same language. This will transform medical records and the potential to do research in our country. So this is another thing that we started using. Traditionally, AI has been used from very beginning, last 10 years for radiology reporting. Because they are patterns, we can check the patterns and the AI is telling us this is the pattern. but it's getting very, very sensitive now. The current AI we have is very sensitive. And look at an example. This was a patient who came to me recently with pancreatic pain, and I did a CT scan, showed pancreatic cancer. It was a little advanced. Normally we diagnose pancreatic cancer advanced stage. Little advanced, we couldn't actually operate, had to give some chemotherapy. This patient had been coming to us for 3 years with some vague symptoms, and fortunately 3 years back he had done a CT scan, same CT scan he had done, which was reported normal. I pulled out the CT scan from our records and showed it to a very eminent radiologist in our hospital, Dr. Tarni. She saw the CT scan and said it's normal, nothing there. We then sent these CT scan images to the Mayo Clinic, one of the top radiologists in the world, the professor of radiology in Mayo Clinic, because we are tied up with them. He looked at the CT scan and said it's absolutely normal. I took the same CT scan and subjected it to our AI algorithm. The AI said, this patient has a potential to develop pancreatic cancer in next few years. So AI predicted, we don't know how it predicted, we know what patterns is seen. We're now going back, sometimes it's called what is called unexplainable AI. It sometimes picks up patterns that human eye cannot see or can't explain and then says. So now I realize that if this patient had 3 years back, we had this capacity, we would have followed him carefully and the first instance caught the cancer. So this is, I think, something which is again very, very important. Unexplainable AI is becoming very important. In fact, there is a study which came, similar study from the Mayo Clinic, where people were doing ECGs for all the people. And the ECG suddenly started predicting that this patient has liver disease, this patient has heart disease. They don't know how AI was doing it. Unexplained way, it was able to do that. So this is again going to something in the future that we have to look at. The other thing that's happening is AI integration into our hospitals. And this is recently we got this bed. It is an intelligent bed. Intelligent bed. Now, we put it in our ICU. What does it do? As soon as the patient sleeps, not only the height, weight, pulse rate and all, which many beds do does, but it also is continuously monitoring the blood sugar. It is continuously monitoring the sodium, potassium, calcium level. It continuously monitoring the other cytokines and so on all the time. It's a very intelligent bed. Not only does, when I start treatment on the patient on this bed, it's got a monitor which is continuously monitoring the treatment response. So patient blood pressure is low, I'm giving him fluid. If the blood pressure becomes more, it says immediately blood pressure more, decrease the infusion. By itself, it decreases the infusion. So there's this interoperability between various devices. And once this bed has come now, I thought, oh, very expensive. How can you put our ICU? Normally in the ICU, for every bed, there are 2 nurses. Normally. When we got this intelligent bed, 1 nurse could manage 5 patients, 5 beds. So you see, ultimately, AI looks costly initially, but once it comes inside. But there are also side of things in this. In fact, I don't know, recently some of you must have heard of a very famous Russian opposition leader jailed in Germany. Not jailed, he was actually put in intensive care in Germany. From Russia, the AI people could hack into this bed, and they started giving all wrong doses, and the patient collapsed. So you see, those dangers are also there. One should be aware of this. These things can happen. But this is a new thing that's coming up. And of course, in clinical decision making, the traditional where AI came in 10 years back was this. I'm a gastroenterologist. I put in endoscopes and I look and see, for example, whether there's a tumor, cancer, this is adenoma. After 40 years of experience, I can now say this is an early cancer. But for now, a novice, a trainee under me can put in endoscope. He doesn't have to think at all. The endoscope says this is a tumor, it's cancer. So it's becoming very easy for people to diagnose this. But there is a the downhill part of it is that we are getting de-skilling of people. Our endoscopy trainees are now saying, why should I learn everything? The computer is going to tell me. So de-skilling is occurring. Again, this is a danger of AI that I should point out to. And of course, we are using it in our surgeries. This is a complex surgery called POEM. And see the red vessels, that is a blood vessel. So as I go near it, the AI is telling me, look stupid, there's a big blood vessel, don't go near this, don't cut it. Otherwise the patient will bleed. So now I take a coagulation forceps, close it, block the blood vessel, then continue the surgery. So AI is becoming an integral part of our surgical techniques. You can actually use it to actually prevent bleeding, prevent complications and so on. But this is more interesting. This is actually Nature paper sometime back, but what happened is in New York when AI first came in their testing, there's a computer vision AI was used where a patient had a skin lesion and 25 top dermatologists in New York City were asked to diagnose what it was. So they gave different, some said it's a acanthosis nigrans, some said it's allergy, some said it's cancer and so on. So it is given to AI. AI checked that and AI said this is amyloidosis of the skin. For doctors who are here, you see amyloidosis of the skin is very rare. Amyloidosis of the skin, nobody would have seen, no dermatologist seen. But AI said amyloidosis of the skin. They took a biopsy of this. 25 top doctors in New York gave different opinion. Only AI said amyloidosis. And they took a biopsy of this and sent it to the pathologist. And pathologist said this is amyloidosis of the skin. So it's believed that many of the specialties like dermatology, I hope there's no dermatologists here, but many of the specialties like dermatology are going to disappear now. Because AI, or if you're planning to send any of your children to dermatology, don't, because the specialty is now. With AI coming in so strong, it's going to diagnose lesions which are visible to this. This is it. And then mobile health, monitoring mobile. It's becoming, all of us are wearing smartwatches, rings, some of them are wearing rings, some of so and so on. Many mobile devices are being owned. And what is happening now is not only the mobile devices are telling us this is very simple, but there is an interoperability between mobile devices is happening. So now we are getting smart toilets. So a few years back, I was asked to give a talk on AI in gastroenterology, the Hong Kong Society. And then I gave this, I was giving this talk that because gut microbiome has become very important, gut microbiome you can analyze and say what is your brain status, heart status and so on. So I made this cartoon which said that you go to the toilet today, they will tell you eat more carrots, increase exercise and so on. That I thought, I was prepared this talk and went to the convention center this January, 2 months back. And in the conventions outside was an intelligent toilet already produced by the Hong Kong people there. And you sit on an intelligent toilet, it tells you today this is your brain, this thing, this is your problem, everything it tells you, It just takes analysis of a stool and immediately will tell you what is the current situation. So just imagine, we have intelligent urinals in Japan. That has been there for some time now. When you go for it, it'll tell you your diabetic status, but this is much more advanced, intelligent toilet. So I mean, our morning sessions are going to be more educative to many of us now, You can get a lot of knowledge also from that. And look at this. Right now I'm experimenting on my health now because of AI. So what I'm doing is I'm wearing a watch which tells me a lot of things, blood pressure, this thing, and VO maximum and all that. It's also I'm wearing a device which is telling me my continuous glucose monitoring I'm doing to know what's happening. I'm in front of such a distinguished audience. Is my glucose going down, heart rate going up, all that. And I'm also wearing a small, I'm experimenting with a small patch here which is telling me what is the level of sodium, potassium, cytokines, cortisol level and all that. And every week I get a gut microbiome done in addition to all this. Now all this data now, right now, is going to a cloud, and from there is going to a AIG AI server where my genomic data, my whole genomic analysis already been done. It's there in that. It's all going there, integrating. Now, after a few months, analysis will tell me several things. What is my health status? What is my metabolic health? What are the potential problems I can develop in future? Is there a trend towards increasing your sugar level? Should I decrease that? Should I exercise more? So personalized health with continuous monitoring with all these mobile devices is going to be the future. Health is not defined as not having disease. Health is now defined as being healthy. And being healthy, you have to monitor all this. So this is going to be the future. AI is going to dramatically change how we monitor health. And this is the first experiment I'm doing on myself. If it's successful, we want to advocate it to others also, so you can keep this to monitor your health. So one of the problems with AI, and this is what actually Professor Shashikaran was pointing out, is that medicine is empathy. Can computers have empathy? Can computer empathize with me? I said no. I thought no, but this changed, my impression changed. This is a paper published in JAMA Internal Medicine, where post-operative patients have gone home, were asked to call back the hospital to say what they have, complaints. Post-operative patients complain a lot of things. I have extra stool today, extra gas today, some things like that. The doctor or the person who's doing gets a little irritated. Oh, that is a small problem. Why do you want to worry? Just leave it alone, that type. So they were asked to ring to a doctor and ring to a computer to see which was more empathetic. And this study showed that the AI computer was much more empathetic, and patients preferred to call that rather than the doctors. So you can train AI to be empathetic also. That is very important. And of course, like I said, now most of my patients prefer to talk to Meera than to me, because Meera never gets irritated at all. So this is for the doctors there, junior doctors, just to give a summarize of what AI can do in different healthcare situations. Prevention, all the life. So now I'm monitoring everything. I know maybe I should do a little extra sleep one of the days or exercise more. Then the data, lab data that comes is not just lab data like this. It's all integrated. Your calcium is so much, your magnesium is so much, because they're all integrated. This is how body normally acts. It doesn't act isolated results, all integrated. And then of course we have clinical decision making can be made on that. Medications, whether it's correct or not, and compliance also is going to be. We can actually now monitor what is the patient's complaints on different areas. So this is going to be a very important thing. But there are challenges. The challenges are, you must have pure data. If you feed wrong data, you get wrong results. So this is very, very important. We have to train our doctors to feed the right data so that you get the right results. Ethics involved, there's a lot of problem. Ethics and regulation is a big problem now. All over the world, not only here. How should we regulate this, AI in healthcare especially? Recently there was a big court case in US where a doctor was doing colonoscopy to detect polyps, and he was using artificial intelligence. Artificial intelligence picks up more polyps than doctors. So 80% of hospitals in the United States now use AI for colonoscopy polyp detection. So use this, and then after a few months the patient developed colon cancer, which means the doctor missed it. And when the patient sued the doctor, the hospital said it's not our fault, it's the AI fault. Now how to sue the AI? So the patient got confused, went to the consumer, and the consumer court came out very clearly that although there's no regulatory thing, it's the doctor's fault, not AI fault. But this is going to become more and more complex. If you have a more powerful lawyer, he'll prove it's AI's fault, and AI, who pays for AI? That's a problem. So this is a complex issue. In fact, we also advise Government of India now that something has to be done immediately. Start thinking of regulations. Where to put the problem? If the problem comes, how we should regulate it. So this is going to be a problem. Also, there is the problem of cyber security. In our hospital now, we have spent at least a few crores of rupees to get cyber security for our data. I didn't realize the importance till November 24th of last year. Data from All India Institute of Medical Sciences was hacked. 4 million data points were taken. It was hacked. We still don't know whom, but they corrected it. But the importance is that in the dark web, if you sell a credit card which is stolen, you get $10. If you sell medical information, one medical information gives $250. So this is the value of medical information, billions of dollars. So we are going to have this problem. Anybody who has large data, especially if you have data of leaders, potential political people, then if it's hacked, it's finished. They can do a lot of things with that. So therefore, cyber security and other things become very important, and this I think we'll have to start thinking of immediately. But AI predictions can go wrong. In 2015, Elon Musk, who is famous now in a lot of things, said that in 2 years' time, 2015, that all the cars will be self-driven. Cars will go off and it will be cars driving by himself. Driverless cars, he said. In 2016, a famous radiologist said, radiology is so good, all the radiologists will become absolute. But 2025, all our radiologists will driving their cars and coming to hospital to report. So sometimes AI can go wrong in terms of prediction. Again, just to summarize what are the pros and cons of AI, you can see that better data-driven decisions, treatment time is cut in half. You can do integration of information. You can, again, reduce hospitals. AI can now predict which patient is likely to come back, which patient not likely to come back based on this. And many administrative users can. But the biggest problem is the high capital investment. I told you about how costly it is to have engineers, and of course, privacy, security concerns, and reluctance of staff. The most difficult people in our hospital to take up AI are not nurses, not healthcare workers, but doctors, especially senior doctors. Some of us have become ancient, we don't want to get back to this AI system, and this is the biggest problem now. And of course, unemployment may not, but I think AI is going to be extremely important because of the economy behind it. It's going to be involving a huge amount of economy, and it's believed that by 15 trillion dollars are going to be part of AI. So AI is going to be the highest economy-driven trade in the world in the next few years. So that's the reason why it will have a big impact. Look at what is happening in I think you have heard of Neuralink. It's a system that Elon Musk is supporting, where in a patient who is paralyzed, a small chip is put inside. And when this chip is put inside, it gives commands to the brain by itself. So you can just think, if the patient is paralyzed, can't move his hand, nothing can help him in this current day science. But with this chip now, he can command his motor area. Hand can be pulled up, hand can be put down. And like what Mohan Rao said, it can estimate the cup to be taken, put to its mouth, and so on. All these are now possible because of this. And this is just a small example. It's going to become again rampant, devices like this for spinal cord injuries, paralytic patients, and so on. Dementias, changing dementias. We are now doing a lot of studies on dementia because it's becoming very common. You can predict which patient is likely to have dementia and then put in the devices to prevent dementia. That's going to be important. So you see, early in life, 2000 years back, agriculture was driving the world. And then military drove the world. World War I, World War II were the ones which actually drove economy. And then it became trade. After that, it became trade. And finally, technology came in. Technology was driving. So 17th century was economy with steam power. 2nd century, mass. 3rd is computing. And 4th, 21st century is going to be artificial intelligence. Here, India has a dramatic advantage. The reason is that unlike, say, industry, mass production, even computing, the amount of capital required to put in for development is extremely less. What you require is capital of manpower, which India has. India has some of the brightest engineers, some of the brightest doctors. It is getting them together, developing a culture of creating AI that's going to make a difference. And just now I showed you examples. All the examples what we use in AI is created by Indian engineers, Indian doctors in a span of 1 year period. And even Western world, when they come and see this, they get very surprised how we could create this, because we have that minds. And that's the major advantage. In fact, that's the reason why we created this Institute of Artificial Intelligence, the first institute in the country in a hospital, where we have engineers, doctors, all coming together, and we have a huge number of projects. And we are also running this health AI course for doctors and engineers along with ISB, this annual course. There's a huge rush for this. A lot of youngsters all over the country want to come. They're doing this course, and they're very, and the government of India, a few months back, the government of US announced $500 billion for AI in different areas. Immediately, the government of France announced $109 billion to develop AI. Of course, we're not so rich, but the government of India has now announced 10,000 crores for AI in these 3 sectors: health, agriculture, and education. And you can see the 7 pillars that they made. One of the important pillars is this AI India Innovation Center. In fact, we formed consortium. Now 5 of us, along with other institutions, have formed a consortium where we are going to now present a lot of AI mechanisms which can help healthcare to government, and they got a huge fund. So, but if you look at 10,000 crores, it looks like only $1 billion compared to $500 US. But with this $1 billion, we can do as good as $500 US. The reason is, as I told you, we have this talent. In fact, I think all of you know the new technology DeepSeek, which China is able to produce ChatGPT at 1,000 the cost of what they could do. This is possible, and this is the chance for us to seize this opportunity and create this world of AI, especially in health, agriculture, and so on, and be ahead of others. So just to remind you, in 2009, in traffic in US, when the traffic is going on in highways, they tell you in the car, those who have been in US will realize that don't take NH9, this is crammed, jammed, take the other road and so on. This was done with this pilot, the helicopter, and then the cameraman is to take it. In 2019, this was replaced by drones completely. Drones were doing it. So in just 10 years, the cameraman and pilot both lost their jobs because of this. So I tell our doctors, upgrade yourself. You are not going to lose your jobs, but a doctor who knows AI is going to replace a doctor who does not know AI. That is very, very important. Because, and finally, to end with this very famous saying of Charles Darwin, it's not the strongest of the species that survives. It's not the strongest economy, the strongest country that will survive. Not the most intelligent one, so-called, but the one most responsive to change. That is the one which is going to become the number one. And that, I think, we have to now, as Indians, take it up. And I'm sure we can become the strongest in that sense. And again, to conclude, as I think I was reminded by Dr. Shashikaran, natural intelligence is still the thing of how we treat our patients. But artificial intelligence is going to play a huge role. We have to adapt to this. India is at now the center of, I think, a great revolution. I just wanted to make this aware to all of you, because when you talk about AI, you think of all sorts of things. I just showed you practical examples of how we can change patient care using artificial intelligence. Thank you very much for your attention.
Thank you, sir, for the scintillating lecture. One or two quick responses or queries if you have questions. The floor is open. So, hope everybody has enjoyed the lecture. So now it is time to felicitate the speaker. Now I invite Dr. B. Shashikaran, Dr. C.H. Mohan Rao, and I also invite Professor S. Satyanarayana and Professor C.H. Sanjeev Reddy Garu to join presenting memento, shawl and check to our chief guest.
With the permission of the family and the Telangana Academy of Sciences, I'd like to do.
Now it is time for a formal vote of thanks by Professor A. Ramchandraya, Editor of Publications, Telangana Academy of Sciences.
Good evening, all of you. It was a wonderful seminar. Hope all of you have enjoyed it and also learned a lot out of it. And We also hope that the Telangana Academy of Science also hopes that all of us are going to be aligning ourselves in our profession to the changing world in the light of artificial intelligence. I take it a privilege to propose a vote of thanks on behalf of the Telangana Academy of Sciences on the occasion of Manohar V.N. Shirokar Memorial Lecture. Madam. అంటే మనకు శ్రీనివాసరెడ్డి గారు లేదు కదా, బదులు ఏజీరావు గారికి ఇస్తున్నట్టుంది. సో ఐ రిక్వెస్ట్ మోహన్ రావు టు ఫెలిసిటేట్ ఏజీరావు ఆన్ బిహాఫ్ ద Dr. Srinivas Garu is not there as director of IICT Hyderabad. He went to Delhi on some important meeting with the ministry. On his behalf, Dr. A.G. Rao is actually helping us in cooperating in holding this particular seminar. I request Professor Mohan Rao Garu to felicitate Sri A.G. Rao Garu and also for having provided us this venue. Thank you. I request A.G. Rao Garu to accept our felicitation. So thank you, sir. Thank you, Dr. Mohan Rao Garu. On behalf of the Telangana Academy of Sciences and also on my personal behalf, we extend our heartfelt thanks to Dr. Nageshwar Reddy Garu, Chairman and Managing Director, Asian Institute of Gastroenterology and AAG Hospitals, Hyderabad, and also for having delivered an excellent talk on the artificial intelligence in healthcare systems. Being a busy doctor, generally we think that doctors are very busy and they may not be finding time to learn the things which are actually currently going on. But being an academician and also very popular doctor, he was very curious and also concomitant with the changing world, and he learned a lot of things. See, by looking at the seminar, all of us must agree that he is actually keeping abreast himself with the latest technologies that are going on in the medical field. No doubt, really he wonders, he is very much deserved to get the Padma Vibhushan Award for doing wonderful things in medical healthcare system and also for being an example and also role model to the other budding young doctors. I'm also thankful to Dr. Srinivas Reddy Garu, even though he is not all here, he is making IICT Hyderabad campus as one of the reliable campuses, reliable offices for organizing any activity for Telangana Academy of Sciences. And I'm also thankful to our President, Telangana Academy of Sciences, and also former Director CCMB, Dr. Mohan Rao Garu, for having presided over and also for having thought of calling Dr. Nageshwar Reddy Garu for this important Dr. V.N. Shirokar Memorial Lecture. Definitely, the most deserved person for delivering this talk has to be naturally none other than Dr. Nageshwar Reddy Garu. Also, we take this opportunity to once again congratulate Dr. Nageshwar Reddy Garu for having been bestowed with the nation's second highest civilian award, the Padma Vibhushan. Even though Dr. Srinivas Reddy is not there, he has deputed his senior most scientist, Dr. A.G. Rao Garu, to look after the proceedings here, and we thank Dr. A.G. Rao Garu for being with us and also for constantly monitoring the proceedings. Our thanks are to Dr. Shashikaran Garu for having introduced the chief guest. Then we are also thankful to Satyanarayana Garu, the General Secretary of Telangana Academy of Sciences, and also the former Vice Chancellor of Usman University, for having provided us an overview and also a profile about the Telangana Academy of Sciences activities. I am also thankful to Professor C.H. Sanjeev Reddy Garu, Vice President, Telangana Academy of Sciences, for introducing the profile of Dr. Shirodkar, on whose name, on whose memory itself we are holding this particular seminar. I am also thankful to all the executive committee members of the Telangana Academy of Sciences for attending, not only for attending this particular program, and also for cooperating in having this particular program successfully conducted. Finally, lastly, but definitely not the least, so we are also thankful to the participants without whom this particular important memorial lecture could not be successful. So we are all thankful to you all for gracing this occasion, and also being very patient and also very attentive to know a lot, especially the young students here. That definitely they must be wondering how this could be useful in their future career. Hope that you are going to be learning a lot from this. We are also thankful to the press and electronic media for having covered this, and hope that this will be coming in the newspapers and also in the media tomorrow. So finally, we are also thankful to the staff of the CSR IICT and also staff of Telangana Academy of Sciences for their cooperation in holding and conducting this program successfully. I now request all of you to stand for the national anthem. Yeah, let us be reciting in chorus. Janagana mana adhinayaka jaya he.
Janagana mana adhinayaka jaya he. Bharat bhagya vidhata. Punjab Sindh Gujarat Maratha. Dravida Utkala Vanga. Vindhya Himachala Yamuna Ganga. Uchala Jaladhi Taranga. तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तव जय गाथा। जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय जय जय